The second question of the exercise is asking us to use prime factorization method to determine the lowest common multiple of the different numbers given. The prime factorization method that has been mentioned in here, let's just understand that first. Prime factorization method is a method of expressing a number as product of its prime factors. So product of prime factors, just as we did in the first question. So now the two numbers that are given to us, 54 and 60. If we have to find the LCM of these two numbers, so what do? First we express each number as a product of prime factor. Again, we can have any one method of the two we know by now, the tree diagram or the division method. In here I have used the tree diagram method. So I have identified the prime factors of it, then I have expressed them as a product. I have expressed the number as a product of the prime factors for both the numbers. Then what we do, we take the highest power of all primes that we have as prime factors for each number. So in here, the highest power of 3, we are having 3 as a factor in here and 3 as a factor in 60 as well. We have 2 as a factor in 54 and we have 2 as a factor in 60 as well. We have 5 as a factor in 60 but not in 54. So the highest power, 54 has the highest power of 3, so it would be 3 raised to the power of 3. The highest power of 2 in here, we are having only 1, 2, so we do not consider this. In here, the highest power of 2, we are having 2, so we will consider this one. And the highest power of 5 is 1, so we will consider this one. This way the LCM would be 2 raised to the power of 2, 3 raised to the power of 3 and multiplied by 5. So when it becomes 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 5. So when we do the multiplication, we get 540. So the lowest common multiple between these two is 540. The next number we are having 54 and 72. Again, we express the number as a product. We express each number 54 and 72 both as product of prime factor using any method. Once that is done, when the prime factors of both are expressed, what we do next is that we use the highest power of the factor. We use the highest power of the factors in here. The highest power of 3 is here with 54, and the highest power of 2, 72 has it, so this one. So this way we will have LCM 2 multiplied by 2 multiplied by 2, and then 3 multiplied by 3 multiplied by 3. 2 into 2 is equal to 4, 4 into 2 is equal to 8, 8 multiplied by 37 because 27, because 3 multiplied by 3 is equal to 9, 9 multiplied by 3 is equal to 27, so 8 multiplied by 27 is equal to 216. So the LCM, lowest common multiple, would be 216. 60 and 72, again expressing each number as product of prime factors using any one of the two methods. Then we look for the highest power of the factors mentioned in here. So we are having 2, 3 and 5. So the highest power of 2 is here, the highest power of 3 is here, in here the power is 1, in here the power is 2, and highest power of 5 is 1, so we are going to take this. This would be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. So we multiply them all, and as a result we get 360, which is the lowest common multiple of 60 and 72. 48 and 60, again we express a number as product of prime factors. Once that's done, we look for the highest factor. So in here, the highest factor, we are having 3 factors overall, 2, 3 and 5. So the highest power of 2 is 3. As we can see, in here it's 2, in here it's 3. So we are going to consider this one. The highest power of 3 is 1, and the highest power of 5 is 1 as well. So it would be 2 multiplied by 2, sorry, it is 4, 2, so 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. When we do the multiplication, we get 240 as the final answer, which is the LCM of 48 and 60. It goes on, it continues. We are having 120 and 180. We express the factors of each number. Then in here, as you can see, the highest power of factor 2 is 3. The highest power of 3 is 2, and the highest power of 5 is 1. So in here we write the common factors, we multiply them, and we get our lowest common multiple. Between 95 and 150, again it's the same, expressing their expressing the number as a product of prime factors using any one of the two methods we know by now. Then we look for the common factors in both the numbers. So the common factors, we look for the factors with the highest power. So in here we are having 5 and 19. So the highest power of 5 in here, in 150 we are having 2, and for 95 we are having 1. So the highest power, we are going to consider this. Then the highest power of 3 is 1, the highest power of 2 is 1, the highest power of 19 is also 1. So what we would do, 2 multiply by 3 multiply by 5 multiply by 5 multiply by 19. We express it, do the multiplication, and we get our lowest common multiple, which is 28, 50. The same is done with 54 and 90. We express the number as product of prime factors, then we underline the largest set of multiples of each factor, or the highest power of the factor. So for 3, this is the highest power with 54, and for 2 it is the same in both the numbers, and then we are having 5. So it would be 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 5. When you do the multiplication, finally we get to 70, which is the lowest common multiple of 54 and 90. 90 and 120. We have expressed the number as product of prime factors. We look for the common factors with highest power. So 3 into 3, in here the highest power of 3 is 2, the highest power of 2 is 3, and the highest power of 5 is 1. So it would be 2 raised to the power of 3, 3 raised to the power of 2, and 5 raised to the power of 1. So we do the multiplication, we get 360, which is the lowest common multiple between 90 and lowest common multiple of 90 and 120. That's all for now. I hope you're able to solve the different question related to prime factorization and able to determine the LCM of different numbers. That's all for now. Happy learning!